Manual labor introduces inefficiencies that directly affect the company: slower process, error rates, and limited scalability. These challenges are not just operational, they translate into lost revenue, inconsistent quality, and reduced competitiveness in the market. That's why we introduce to you the Cantonian method, a smarter, more scalable approach designed to transform how packaging operations work. Today, Manchester Robotics process relies only on human labor, resulting in packaging only 2 kits every 15 minutes. This not only constrains the output, but also increases the risk of human error and bottlenecks. In the current state, the system limits the growth and makes it difficult to meet the demands efficiently. The Cantonian method addresses these limitations, unlocking higher production capacity, improving consistency, and creating foundation for a more scalable and reliable operations.
For the solution proposed, we have enclosed working pens for safety reasons, 3 emergency stop buttons, scalable feeders, 5 times faster cycle time, vision system, semi-automated process, and realistic investment. As you can see, the design of this gripper is very human. It's meant for palletizing, and it basically works as it follows. It has 3 different parts that get into another positive part, and it can get below the box easily. Okay, so this is a custom-made parallel gripper, which is meant to wrap all of our components, and in a moment you'll see how does it fit all of them.
So we made different feeders, one for each of the components we will be using. They are gravity feeders that will have a container with a slot in the bottom that will be pushed with a motor in order to deliver the components in an grabbing position for the gripper.
Okay, so for our robot selection, we decided to go with 2 ABB's IRB 140 robots, which have 6 degree of freedom axis manipulators, as well as 6 kilograms of payload, which is more than enough for what we need, and has a reach of 810 millimeters.
So for our vision system, we selected the Cognex camera, the model Insight 7905 in color, and we selected this because it has the appropriate range for the area where we will be placing all our components.
For our system, safety was one of the main design priorities. All the robotic work area is enclosed with safety fencing to physically separate the operator from the moving robots and feeders. We also integrated 3 linked emergency stop buttons, one near the HMI where the operator supervises the process, another near the system output area, and another inside the cell, which follows the RFQ requirements of industrial safeguarding. In terms of efficiency, we reduced the cycle time considerably compared to the current manual process. We maximized the robot's capabilities to undergo repeated tasks with a practical trajectory and feeder approach. We also added a vision system to improve repeatability and reduce manual inspection errors by verifying the package condition and component placement.
The main risks are related to part feeding, object orientation, and safe human interaction with the cell. To reduce them, we designed our feeders that will present the components consistently to the robot. The fence layout and emergency stops reduce safety risks, while the vision system reduces quality risk, and overall the solution balances automation, cost, safety, and scalability. So as you can see, we designed a semi-automated process instead of a fully automated mechanism that would increase cost and complexity. Our investment is more realistic to the company, and it is helpful for automating simple, repetitive, and time-consuming tasks.
This is the vision system simulation of the Insight Cognex emulator that shows the camera verifying each component arrives at the pieces and counts them all.
Well, for our financial analysis, here we have a full breakdown of the cost we have. The cost for the 2 robots, the 2 custom grippers, the personnel, and the installment of the robot and the grippers, which comes to a total of $61,000, a conversion to 45,000 pounds. We assume Manchester Robotics sells 1,200 robots per year at a price of 199 pounds, coming to a total of $238,000. And assuming we have a 30% profit, it comes to a total of, before income and taxes, of 71,640 pounds. We did a net present value chart to see how the investment will look in the next 7 years, taking into account the inflation. We see that after 7 years, we have a return of 456,000 pounds and internal rate of return of 169%, including the same 7 years.
As you can see, our proposal is a friendly budget semi-automated solution that can be easily escalated. Even though it does not achieve the performance targets, it is faster than what the operators currently do. Automation is not always meant to replace humans entirely, but they can work together and make a process more efficient. Thank you.
This is the video demonstration in which we show the station with the custom gripper designs, custom feeders. We also show the robotic arms, the safety measures such as the stop emergency buttons and the safeguards, the fences, and the vision system. The current cycle time is 1 minute per kit in the slow speed template, making it at least 7 times faster than the manual process.